Okay, our topic today is reasoning about context with tape diagrams, part 2. So yesterday we did some work with tape diagrams and how the tape diagrams are representing an equation. And our focus question today, how can you represent an equation with a tape diagram? So the first question is select all the expressions that are equivalent to 7 times the quantity of 2 minus 3n. Explain how you know each expression you select is equivalent. So there's a couple ways of doing this. First way is we can use the distributive property. And if you remember, the distributive property is if we have a times b plus c, then we multiply a times b is equal to ab plus a times c, ac. So if we use that on this problem here, 2 times 7 is 14 minus 7 times 3n is 21n. So we're looking for an equation that looks like this. So we have 14 minus 21n, that looks exactly like what we have. But there's also number 4 here that's also 7 times the quantity of 2 minus 3n. All they did was the commutative property of multiplication says a times b is equal to b times a. That's the commutative property of multiplication, so they just switched the terms around here. Another way of solving this is you could put a value in for n. Say we put 2. So we make n equal to 2. So 3 times 2 is 6. 2 times 6 is negative 4. So we have 7 times negative 4, which is equal to negative 28. So we can see which of these is equal to negative 28. So if we put a 2 in here for n, 10 times 2 is 20. 9 minus 20 is not equal to negative 28. 3 times 2 is 6. 14 minus 6 is 7. That is not equal to negative 28. 21 times 2 is 42. So 14 minus 42 is equal to negative 28. And if we put a 3 in here, or a 2, 3 times 2 is 6. 2 minus 6 is negative 4. Negative 4 times 7 is equal to negative 28. And if we put a 2 in here, negative 3 times 2 is negative 6. So 7 times 2 is 14. 14 times negative 6 is not equal to negative 28. So we still have these two right here, 3 and 4, that are equivalent. Okay, let's move on to question 3.2, matching equations to tape diagrams. So question 1 says, match each equation to one of the tape diagrams. Be prepared to explain how the equation matches the diagram. So we have our list of tape diagrams here, our list of equations here, and we're going to see what equations match the diagrams. So let's look at this first tape diagram. We have a 5 plus an x plus another x is equal to 19. So this is basically saying 5 plus x plus x. And we could take this x plus x to mean 2 times x, right? 2 x's. So 5 plus 2 x's is equal to 19. So I'm going to look at this equation here and see if I have anything over here that matches that. So we have 2x, 2x's plus 5 is equal to 19. That's pretty close. And since we have a commutative property of addition, we can switch these terms around and it's not going to make a difference. We could say 5 plus 2x is the same as 2x plus 5. So this one matches A. 2 plus 5 x's. So we have 2 x's here, not 5, so that one doesn't match. 2 times the quantity of x plus 5 is equal to 19. We have, that means this one would be like 2 groups of x plus 5. So this would be equal to x plus 5 plus another x plus 5 is equal to 19. So that's not quite what we have here, right? So let's move on. What about this one? This one has 2 x's plus a 5. And that's the same as this one, right? 2 x's plus a 5. So this could be A or B. Let's look at this question C, or tape diagram C. We have a 2 plus an x plus an x plus an x plus an x plus an x. We have 5 of those, so we could say 2 plus 5 x's is equal to 19. So let's see if we have any of those over here. There's one right there. 2 plus 5 x's is equal to 19. So that could be C. Okay. So let's look at this one. Let's look at D. We have a 5x, or an x plus 5, and an x plus 5 is equal to 19. So we have 2 x plus 5s. So let's see if we have any of those. 2x plus 5 is equal to 19. That's what we have here, right? X plus 5 plus x plus 5 is equal to 19. So this one matches with D. We have this one down here. We have x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. So we have 5 groups of x plus 2. So that one would look like 5 groups of x plus 2 is equal to 19. So here we have 5 groups of x plus 2. So this one would be E. We're running out of tape diagrams here. So let's look at this one, see if this matches anything we've written so far. 5 plus 2x. Just like this one, right? Commutative property. So this would be also A and B. So we have x plus 5 times 2. So we have x plus 5 here times 2. They just switched them around, right? They just used the commutative property of multiplication to switch the terms around here to equal 19. So that one would be D. And then we have 19 is equal to x plus 2 times 5. So if we look at this one, we have x plus 2 times 5, but they just switched them around, the commutative property of multiplication again. So that one would be E. So these two are a little bit different. We have 19 divided by 2 is equal to x plus 5. So let's take this 19 and split it into two equal parts. So we have this part here. We split it into two equal parts. So if we divide 19 by 2, this whole thing is 19 cut in half, divided by 2 is equal to x plus 5. So this one is D. And then we have 19 minus 2 is equal to 5x. So let's see, we have this one here. If we take 19, this whole thing is 19, and we take away 2, we're left with 5x's. So 19 minus 2 is also equal to 5x's on question C, or on tape diagram C. All right. So moving on to 3.3, drawing tape diagrams to represent equations. You notice there is an interactive digital version for this, and I showed you how to work on that in a previous video. But we're just going to draw them. So we have, let's work on this one here. 114 equals 3x plus 18. 114 is equal to 3x plus 18. So our total is 114. So when I draw my tape diagram, the first thing I'm going to do is draw a rectangle. And my total here is going to be 114. And now I got to split this up into parts, right? I have a part that's 3x's plus another part that represents 18. So I'm just going to split this. I'm going to make this separate. This part and this part. So I'll have this part equal 18. It doesn't matter which side I put it on. And then I have this 3x. And I know that 3x is the same thing as x plus x plus x. So that's what I'm going to put in this part of my tape diagram. I'm going to split it up into 3 equal parts, and each part is going to have an x. So there's my tape diagram for this equation. Let's draw a tape diagram for this equation. So the first thing I'm going to do is draw my rectangle. And this one is going to be 114 is equal to 3 times the quantity of y plus 18. So my total is going to be 114, and 3 times the quantity of y plus 18, 3 times the quantity of y plus 18 is the same thing as y plus 18 plus y plus 18 plus y plus 18. So I'm going to split this up into 3 equal parts, and each part is going to be y plus 18. Okay, so part number 2 says use any method to find values for x and y that make the equations true. So just like we did yesterday, if I want to find out what x is, the first thing I'm going to do is I'm going to take 18 from 114. That will leave me just the x's, right? If all this is 114 and I subtract the 18 from that, 114 minus 18 will give me 96. So these x's right here are equivalent to 96. So I have 3 equal parts. If I split that 96 and I take 96 divided by 3 equal parts, I get 32. So in this case, x is equal to 32. So let's go over and look at this one. Well, before I do that, I want to go back to this one here. Another way of writing this, 114 minus 18, right? 114 minus 18 would be equal to just the 3 x's. So this equation here, 114 equals 3x plus 18, that could also be written as 114 minus 18 is equal to 3x. So these are equivalent. Let's look at this one now. So if this whole thing right here is equal to 114, if I divide that into 3 parts, if I take this 114 and divide it by 3, that's just going to leave me y plus 18. So I'm going to rewrite my equation here. 114 equals 3 times the quantity of y plus 18. If I take this 114 and divide it by 3 equal parts, that is going to give me y plus 18, right? Well, what's 114 divided by 3? 114 divided by 3 gives me 38. So 38 is equal to y plus 18. So what number plus 18 is 38? If I subtract 18 from 38, I get 20. So y is equal to 20. So let's go ahead and do our notes. So how can we write equivalent expressions? Well, if we're looking at a tape diagram, and there's different ways to show this tape diagram, we could say that 26 plus 4x is equal to 46. 26 plus 4x is equal to 46. But we could also use the commutative property of addition and switch these terms around. So 4x plus 26 is equal to 46. We could also arrange the where these numbers are on which side of the equal sign, right? We could say 46 is equal to 4x plus 26. So we could just take them and move them on the other sides of the equal sign. That doesn't matter. And we could also say that if this 46, if we subtract the 26 from 46, that leaves us with the 4x's. So we could say the 4x's is equal to 46 minus 26. In this tape diagram down here, we could rewrite this as 4 groups of x plus 9. So 4 times x plus 9 is equal to 76. And using the commutative property of multiplication, we could switch these around, right? 4 times x plus 9 is the same thing as x plus 9 times 4. And we could also say, if we take this tape diagram that represents 76 and divide it into 4 equal parts, right here, that leaves us with an x plus 9. So we could also say that 76 divided by 4 is just equal to the x plus 9.